Skewness, sir, it should be 0 ideally.
Yes. Oh, what is skewness?
So basically, it's a angle between the adjacent edges of the element.
Okay.
In brief, we can say, but
Mhm.
uh, in more detail, it will be the median angle minus the angle between edges, and that will be 90 minus theta.
Okay. What about others? I think only. Yes. Anyone else can answer? What is orthogonal quality? What could be the best preferred value of orthogonal quality? Yes, what is the best value of orthogonal quality? Like skewness of 0 is best preferred, or aspect ratio of 1 is best preferred. Then what about orthogonal quality? Yes, anyone? Yes, anyone?
Yeah, actually, most of them are have not done any basic course in FEM, and they are not aware of any simulation software as of now. So they I do not know
Okay,
the
okay.
exact keys.
So what is meshing, and do anyone know why we need to go for meshing? Yes, what is meshing? I hope you learn already about the meshing. Yes, come on. I think I can keep on speaking, but if I don't know what exactly you know, other it will be difficult for me to teach. Right? Okay. Please tell
Dear
me.
participant, if you have any, if you wanted to know the answers, you can please say that, sir, we don't know, please learn it. It is fine. There is no issue in it. Yes, now we
Yeah,
are getting the answers. Meshing is
Okay, I
discretization
think you
elements.
can even unmute yourself. It is fine. Okay. Discretization continues to. Okay. Okay. Accurate simulation. Fine. So why exactly we need mesh? Yes. So someone like Sudesh, Sudeshna. So saying like breaking in into elements so that we can analyze. Okay. But why we need to break into elements only to analyze? What is the reason? Okay, to convert our element into finite degree of freedom for easy analysis. Okay, to analyze the element into small. But why? Okay, so basically, meshing is nothing but a discretization of any continuous body into finite number of small elements. That is what called as meshing or a discretization. Okay, um, or grid generation. So why exactly we need to go for the meshing? To find the value of displacement and deformation at finite level. Okay, so that we can the computational time reduces. No, if we won't discretize, then we don't need even much time to solve the problem, right? It's not about reducing the time. Yes, what else? See, basically meshing is required, so that we can solve the various partial differential equations or the finite element equations on each element. So let me give you a brief idea about meshing. So meshing is nothing but a discretization or dividing a continuous body into a finite number of small elements. That is nothing but a meshing. So why we need meshing? So we can solve the various finite element or flow equations on each control volume. Whatever the each element is nothing but it is called as a each control volume. So if we are talking about different then we have different methods over there. So then why again we can solve the geometry, we can have a good representation so that we can apply the boundary condition at specific locations. That is the reason we need a mesh. So what are the different significant impact of mesh on the various things like we have the rate of convergence. So exactly what happens, so let's say we have a one bar of 10 by 10 by 100 and we are dividing it into let's say 100 elements. Okay, so let's say now I want to solve the equations for each node point. So whatever the number of nodes generated for that 100 elements and whatever the time it will take. Let's say it is taking 5 minutes to solve that particular problem. And then let's say what I did is next time I have again discretize it further to 200 elements. Then ultimately what is going to happen, software has to solve these equations for more number of nodes again. So definitely your time will be increasing. So with this what happened, your solution time or CPU time requirement that will be increased. But with this what will happen, when you are solving the equations 100 times for the large elements and when you are solving it for 200 times for the small elements, so you will be able to capture that result variation when you have more number of nodes. So with increasing in number of elements, your solution accuracy will be increased, but your CPU time requirement will be more. Means it will take more time to solve that particular problem. Again, whatever the convergence criteria we set, if we are having more number of elements, the convergence will be taking more time to get converged. Solution will be taking more time to get converged. So these are the different impacts of a mesh on these different factors. So that also we need to understand. So let's say you are creating 1,000 element or 5,000 elements or 1 lakh elements or 1 million elements. So depending on the problem, depending on the requirement of solution accuracy, sometimes you are not much interested into getting only the results, you are just interested in finding out the area where we are getting that bad quality or weaker part or maximum deformation region, etc. So we are, if interested into that and not much into the accuracy of the solution, then you can have a little coarser mesh also. That will help us to get a faster solution in a lesser time. Okay, so that is how we can solve this problem or complete it faster. Okay. Okay, so now see why we need mesh. So here you can see um, we have two different methods over here where problem can be solved. In finite element or for FEA we solve with the finite difference method where results will be solved at each node point, and whereas in finite volume method the results will be solved at each control volume and the results will be stored at the cell center. So these are the called as cell centers over here. Okay, so like in 2D we have this types of element like triangular, quadrilateral. In 3D we have tetrahedron, hexahedron, pyramid, wedge, prism, then polyhedron, polyhex for different types of elements available. Now the nomenclature which is very important. So here you can see in case of 2D, now whatever the plate problem we are solving, that is a 2D problem. So this point joining the element is called as node point. the side of that particular element is called a cell. This is complete cell or element, and this is a cell center over there. Whereas in 3D we have this node point, this is the complete edge, this is the face, and this is a complete cell over there. Okay, so I hope you understood this. Now okay, we'll move back to the our problem. So depending on the you know the type of model we have, we need to choose what kind of mesh we have to create over there. So for this kind of problem, if it is in 2D, we can definitely go for a very good structured mesh, but just for a time being I am solving it with the unstructured mesh over. Okay, so let us see. Now I have created this complete model over here, or I have created the complete mesh with 1.5 mm elements. So let's say I'll make it a final of 1 mm elements, and then we'll move to the next part. Okay, I try to create all hex elements, but still it is not creating in a proper way. So you can see they are just giving randomly placed elements. Okay, and with some bad quality cells as well. So to understand that, we can just check out the display style. You can change it to, let's say, element quality, where you can understand. So there are some elements where we have the element quality of 0.25, that is 25%, so which is a bad one, right? So if you want, you can improve the element quality in those regions. So let's see here. Here we have the element quality, which is a bad one. Okay, so you can improve that particular quality elements as well. Okay, so once we're done with the mesh, then now we need to go for the static structural, where we need to give the pre-stress conditions to the model. Okay, so let's say we have this plate fixed on these two edges. Okay, so let us add the static structural, go to the insert and add the fixed support. So let's say we are adding fixed support on this edge and this edge. So go for the edge selection with this, select this edge, use control and select the other edges, click on apply. So both the edges are selected only. Okay, so there we have applied the fixed support. Now again right click on static structural, insert, and let's say we are going to apply the force conditions. So let's say we'll have some force on this circular profile or the whole side. Okay, so click on apply. So let's say we are adding a downward force. So in the downward direction we have negative y-axis over here. So change this from vector to the components, and here we can give minus 9.81. Sorry, not gravity, we are adding some let's say 1000 Newton force, so it should be minus 1 kilonewton force that we have added over it, as you can see this location. When you click on this static structure, here you can see at A and B we have the loading conditions or the boundary conditions. So at B we have fixed support, and at A we have the force of 1000 Newton. Okay, then once you applied the required condition, now we have given some pre-stress condition to this plate. Okay, and now just simply right click on static structural and solve. Okay, here you can track the progress. Okay, so problem is solved. If you want to see the stresses occurring, so you can go to the solution, right click, insert deformation total. Then you can add another, like say you want to add stress values, so right click on solution again and evaluate all the results. So here you can see these are the stresses which are generating into this. So I'll just remove the one. So you can see stress generating over here. So this is the deformation and this is the stress value, these locations. Okay, so as you can see we are getting a maximum stress of 726 MPa. Okay, over here, and then we are getting the total deformation of 3.4717 mm. Okay, now this is not actual true scale, it is in large scale. If you want to see the true scale, you can just see over here. So this is how, this much is the difference that we are getting in actual case. Okay, if you expand it, you will be able to see that with this you can just scale up the result so that you can
Yeah.
see the proper variation here. Yes, any question?
So there is a question in the chat box. There's
Okay.
a query in the chat box.
uh, Type of the solvers. um, in what way? We have the FEA solvers, we have various CFD solvers. Basically, here we solve with a finite difference method or a finite volume method. Okay, so in CFD, we have explicit implicit solvers. In FE also we have explicit implicit solvers. So depending on problem to problem, we need to select the various analysis systems depending on the problem requirement. So let's say you want to solve for the impact analysis, then you can go with the implicit solvers or the explicit solver depending on that. So you have that, for that we have this ls dyna over there. uh, then in fluid flow fluent also we have various implicit and explicit solvers available. So depending on the problem to problem, we need to select the different analysis system, or we can say the solvers. Okay, so any other question? Yeah. Okay. Okay, so once we solve the problem, now as you can see, if you go back to the workbench, you can see that complete static structure is solved. And this one is solved till model. Setup is not solved. Why? Now this results we need to take it to the setup. So if you just scroll down in the same window over here, you can see new steps are added. So let's say this one, we have model B5. So you can see this B5, this b5 and 6 are added over here, b5 and 6. Okay, so this was the a5 a6. Okay, once this is done, then now we have this b5 and b6. Now here you can see we have the pre-stress condition is already taken from static structure. Okay, so that is how it will automatically take that pre-stress condition, and you don't need to add any boundary condition over there. Nothing required because boundary conditions are already given in static structure. Okay, so it will follow the same boundary conditions. Only what here you can solve is for the different mode shapes. So let's say we are solving for 5 mode shapes, or let's say eight mode shapes. Okay, so you can add 8 mode shapes for to find out the various frequencies to related to each mode shape and what is the deformation for that particular frequency. Okay, so all those things you can find it out. So let's say you have solved this problem, so just right click on model. Now click on solve, so it will solve the problem. Okay, so problem is solved, then just click on solution and you can see all 8 more frequencies related to 8 different mode shapes. Okay, and now to get the deformation data, so just right click on this graph, click on select all, again right click on the same graph, and here we have option create mode shape results. Click on it, and here you can see it will add all the deformation results over here in this area. Okay, just right click on solution again and then go for the evaluate all the results, and here you can see the complete result evaluation or the deformation with pre-stress condition now. Okay, so you can see the various mode shapes. You can just uh, animate this, so you can just go for the uh, time stepping or the animation duration. You can give the number of frames. If you want, you can just save this animation. Let's say I want to save in on desktop, just click on ok, and now this animation will be played and the same time it will be saved on the desktop. Okay, so you can see once done, then you can just go to the desktop. Here you can see this file will be created, and here you can see you will get this complete animation as well. So this can be used to you show in your presentations, etc. So that can be helpful. Okay, so like this we can create an animation over here, and once this is done, if you want, you can give the okay. Okay, so this way we can create animation and you can save the animation as well. Once this is done, now you can check out the different deformations related to each frequency. Now whatever this complete data you have, if you want to add this data or share this data or save this, so you can go to the report view. Here you can generate a report. Click on generate and it will generate the whole report of the complete results. Okay, from the pre-stress condition till the model shape, different mode shapes. You can see you will get a complete detailed report over here. Okay, but here you will see that none of the result or the contour is added into the report. Let's say I want to add a specific contour over there. So let's say I want to add deformation contour. Okay, so what you want to do is go for this deformation control, just select this, and here we have option in the results, we have option image. Just click on this figure and this figure will be captured. Similarly for the stresses also you can do this. So we can see both the figures are added. Apart from that, now for this deformation also, if you want to add, so you can add the figures. Okay, like this. Select the result and then just click on image on figure, it will add that. Again go to the report preview. Now we need to regenerate the report. Just click on generate again, and you can see now all the figures will be added over here. Okay, so here you can see the complete results will be added along with the all images, as I said. Okay, so results for all the mode shapes are added over here. So like this we can completely generate the report. You can just use this to public for the publication, or you can just print this. So let us try the print, and you can just save it on Microsoft print to PDF. Okay, so click on print and it will ask you to save at certain location. So let's say I'll save it on this, or I'll create a new folder here. Okay, new folder 5. Okay, and here you can give the name, let's say report. Okay, you can see it will be added over there. Okay, you can see the complete report will be added over with even better quality images as well. So no need to take a screenshots or anything. Automatically it will add all the images as well. Okay, so this way we can completely perform this model analysis for the pre-stress condition. So any doubt in this, any question? No questions? Okay, then I think you can try the same problem and let me know if you face any difficulty. Okay, so I'll be just waiting here itself. So please try out the problem and I'll then call one by one to share it that screen. So make sure that everyone will try this. Okay. Yes, please let me know if you have any doubt, or otherwise please try this problem and let me know if you have any question.
Yeah, Mr. Kailash, probably you can share the dimensions that they need to consider for the plate,
Just a
or
moment, sir.
if you have the built-up model otherwise.
No, I think they can create it, and that will
Yeah,
help them
sure, sure.
practice as well. So yes, so we have
Yeah,
this
sure.
model. So if you want, I will just take a drawing sheet. Okay, I think it will be better to understand. I hope you can see the dimensions.
Yes, it is visible.
Okay, I think. Okay, you can see it's just a simple plate of 200 by 100 mm, and there is a hole at the center of 25 mm diameter. Okay. So, and in the meshing, you need to give a thickness of 2 mm to this sheet. Okay.
Hello, sir.
Yes.
Sir, can you repeat the step of the connections between static structure and model one?
Okay. Okay. Yes. So what you need to do is you need to take this static structural first, like this. Okay. And when you add it, then you need to take a modal analysis and drop it on the solution. Okay, directly drop it on the solution, so automatically connections will be created. Clear?
Okay, sir. Thank you.
चलो one by one show करो किसी ने like how much you have completed. If you have any questions, let me know. Starting with Abhinandan. Yes, please share your screen. Yes, can you hear me? Yes, Abhinandan.
He says that he's doing the chat box. He has responded.
Okay, I'm doing, sir. Okay. Okay, then we'll move to the next. Aditya Singh. Please show your screen. Let's see if I can help you when you are getting any issue. Otherwise, I won't understand if you are just practicing or what. So just show me your screen. So if there is any issue or any difficulty, I'll be able to answer it. Okay. So yes, Aditya Singh. Okay, there are two names, Aditya Singh. Yes, please share the screen. Yes. This should not be the answer. There is a lag or still loading. Okay, next Anurag. Sorry, Anugrah. Sorry, Anugrah. Yes, please. At least show me what exactly you have done. Anugrah. And this doesn't mean those who have skipped, they don't need to show it. I'll again, after completing, I'll again come back to them. Okay. So if you have any doubt, ask it right now. Otherwise, at the end, you should show me the complete problem. Yes, please. Anugrah. Okay, then Chitnis Swapnil. Yes, come on. At least show me what exactly you have done. Yes, no one is going to show. Or you
Yeah,
are not
please,
able to understand.
yeah, please respond. Alma, please respond. What is the issue you guys are facing while performing?
Yeah. Yes, if you are facing any issue, let me know so I can, clear that out. Otherwise, it will be just a one-way communication. Yes, Chitnis Swapnil, please share your screen. Yes, next, Devender. I think you unmuted yourself, so I think you can share your screen. Devender. Yes, anyone at least, or I just need to keep on calling names. Sir, actually, the total deformation you have added is in a wrong way. You need to click on solution. Hello, am I audible? Yes, click on solution and then you will be getting a graph in the center. You can see. No, don't right click. Just see in the center of the screen. There is a graphs. These are different graphs which are coming. Just expand that. You can expand that by pulling it in upward direction. Yes. Yes. So right click on that. In the graphs, right click. Click on select all. Again, right click on the graphs. Create mode shape results. First option. Yes, so that is how you need to add it. Now right click on solution and evaluate all the results. Yes, and you can see different mode shapes and the results related to each mode shape will be there. Okay. How much thickness is given for the plate? Okay, go to the home, reset layout. So it is 10 mm, so which is too much actually. Okay, so that is the reason we are able to see the plate of that larger size. So we can have 2 mm or 3 mm. That's enough. Like what I have done was that is for 2 mm. Okay, yeah. Then you can again resolve it. Yes, so this way we need to try the problem. So like how sir, or who has some Vikesh. So very good, and you should take a initiative to show what exactly you are doing, right? This was a good one. So who else want to show? Then Dinesh. Okay, Abhinav. Yeah, one by one, one by one. Those who want to show, they can just raise their hand. So I will call one by one. Okay, so you have added 4 total deformation results. Why that so? That is the wrong one actually. Okay, so just delete all of them. Delete all total deformation results. They are not required. Right click on it and delete. Yes. Yes, so that's what I said. If you won't show me, I won't understand what problem you are facing and I won't be able to correct it. We whatever the in model analysis, whatever the results we add, that we don't need to add it by right clicking on solution. This thing keep in mind. Okay, what we need to do is we need to click on that graphs in the bottom side. Okay, then right click on it. Just right click on the graphs, click on select all. Again right click on the graphs and click create mode shape results. Okay, and there you can see if you scroll down in the solution, you will be able to see all the results now. Okay, yes. Okay, so Desh now, yes, please show your screen. Yes, please show the screen. Okay, problem is not yet solved. Why that's so? Just go scroll up. Even mesh is also not created as of now. So okay, mesh is created. Right click on static structural. Right click on static structural and solve. Second option. Okay. Then right click on model and solve it. Solve it. What happened? Right click on model and solve. Just solve one step by step so that you understand if there is any error. You can just simply click on top side solve, but that will not able to that will solve the complete problem. So just solve in step by step. Okay. Now once this model is done, then now we can just add the results. Okay, and you can see now the results are added. Now you can check various deformations. Okay, who else? Saurav Kumar. Yes, please share your screen. Yes, please, Saurav Kumar. Sudeshna, if you, I think you have already shared the screen, so you can just lower your hand, or I just lower it. Okay, Saurav. Okay, right click on solution and evaluate all the results. Okay, so you got all this. Just click on that total information under the solution. Okay, next is Viti Kumari. Okay, I think it is already solved. Okay, good, very good. Okay, very good. Who else want to ask any query or doubt in your simulation? If you have any queries to discuss, let me know. Yes, anyone want to share the screen and show me if you are facing any issues? Yes, a report can be generated very easily. So just go to the report viewer. Okay. Yes, anyone else? Or shall we move further? Yes, I think out of almost 25 people, only 4 5 people have solved. What about others? Are you facing any difficulty? Okay. Mm, fine. So now we'll move towards the next problem. Okay. Just give me a moment. Okay, we'll create one profile over here. Now we'll see the next problem, that is of okay, so we'll see the next problem of parametric study. So what is parametric study? So this study is performed to understand what is the effect of on the results by changing certain parameters. Okay, so let's say if you talk about this particular problem, so let's say here we have this particular sheet. Okay, what if I initially I have given the thickness of this sheet as 2 mm, and let's say I
Yeah,
want to try out.
yeah,
Yes.
are you sharing the screen? I cannot because we
Oh,
cannot
okay,
see
okay.
it.
Sorry, just a moment. Yeah. So let's say in this particular problem, so let's say initially I solved this problem for 2 mm thickness. So let's say instead of 2 mm, I want to check out for the, let's say, 1.5 mm, 2.5 mm, like how much weight is increasing and whether what are the results we are getting, whether those are changing or what. So that is what how the results are varying, that we need to understand, and that is completely depending on the uh, modes, that is called as a parametric study. So by changing a certain parameter, what is the effect on the results that we'll be getting, that we need to understand over it. So many times what happens, so we go for certain over designs. So what I mean by over designs, like um, uh, let's say you are designing a chair and it should sustain let's say 50 kg of load, and but you are designing in a such a way that though you are keeping a 100 or 100 kg of load, it is still sustaining that. So what exactly it means is our requirement is of only 50 kg, or it should sustain a weight up to 50 kg. So let's say with the safer side we are designing for 60 or 70 kgs, but if we are designing it for 100 kg of load, and what exactly it is happening over there is you are going for a over designed cases. So that is something not required. That will unnecessarily add more material, and that will make a model as a mm, I know weight to the model. So that thing we don't need, right? So that for that purpose, parametric study is very important for us. So for that, let us say I will create a model. Mm, Let me share the new screen. Just a moment. Okay. And let's say we are going for a simple static structural analysis. So we'll go with the uh, this same engineering data. We'll just add the okay. So just launch this specific. Okay, and let us say we'll create a model over here. So we'll create a rectangular profile on this XY plane. Okay. Let's say it is 50, 100 by 5 mm. Okay, and return to 3D. And I'll create a path. Okay, on this plane. Let us say it is 150 by 150. Okay, return to 3D. Okay, sorry, not return to 3D. We need to give some rounded corners. Let's make it as 50 and then return to 3D. So what I have done is I have created a profile and a path. So let's say I want to pull this particular profile along this particular path. Okay, so it is created. Okay. So once the model is created, now you can see I will add a rib over here. Okay, so which will connect both the um, sides together. Okay, or it will give certain support over there. So let us go to the design, create a design on this particular plane. Okay, and let us create it of let's say it should start from the it is 150, right? So it should start from 100. So take a cursor to this location, press shift and give the uh, this as -50, and it should go till here. How much it should be? Okay, what we'll do is we'll project this project to sketch. Okay, this edge, this edge, and this edge. Okay, so from the midpoint of this edge, we'll draw till the midpoint of this edge. Okay. This midpoint is nothing but a 50 mm only, correct? So trim excess part here and here. Now if you want to measure it, press E to measure this, and here you can see it is of 50 mm, or this one is also 50 mm. So you can see from this point till this point it is 50 mm. Okay, so it is correct one from this point to this point. Okay, so done. Return to 3D. Okay. Indexes. It has created unnecessary edges over here, so just remove that. So now it is a closed loop. Yes. Okay, and now we need to pull it on both the sides. So let's say we'll pull it on both sides, and let us give a thickness of 5 mm. Okay, done. And now we'll add two holes on this faces. So let us say in the middle, press shift, and let's say it is at 25 mm. Okay, sorry, press shift, should be minus 25, and here let us create a hole of 10 mm diameter. Okay, it is too small, let us make it as at 20, and it is of how much is possible, 20 mm will make it. Okay, so similarly we need to create it on the other face as well. Just remove it, so hole is created. Similarly we need to create another hole over here, on this face. Again, take a cursor over here, press shift to take the reference. It is 20 mm, and here it is 20 mm. So return to 3D and press H for home view and remove the material. Okay, so we have created this bracket over here. Now what we need to do is go for the selection, select this face and use control and select another face over here. Okay. Okay, so what we can do is use ruler over here. Okay, so take a pull command, select this face and use ruler up to this face. Okay, and okay, cancel. Once we add this ruler, click on this P. So this parameter set will be added into this group. So you can see this ruler dimension. So it is added over here. Now let's say instead of 5 we want it as of 7. So you can see it will be added over there. Okay. So we have added this, thickness as a parameter over here. Now with this changing in thickness, how the stresses will be changing, that we need to understand over it. Okay, so when you have created these two models, so okay, it is single model. So changing in the thickness of the model. Okay, so with changing in this thickness, so we need to understand how the stresses generating in the model will be changed. Okay, so what we are going to do is we are going to fix this face, okay, over here, and this face as well. So like it is fastened on the some surface, and there is some load applied on this part. Like let's say there is some other component which is attached on this side, so it will be having certain loading on the, or else it will give certain stress onto this bracket, and we need to understand how the that's deformation in the bracket or the complete stress in the bracket will be changing when we are changing the thickness over there. Okay, so just a moment, I'll just uh, okay, so yes, understood this. Actually, we don't need to add a mm, thickness over here, so we have to create it as a surface body. So what I'll do is I'll just undo this. Let it be. I will convert it to surface body.
Yes, screen is not visible.
Okay, so you can just go to prepare and go for the mid surface.
Yeah, your screen is not visible, Mr. Kailash.
Sorry, yeah, sorry. Okay, so what we need to do is, so we have this model. So go to the prepare, and here we can take the mid surfaces of the models. Mid surface is not possible. Okay, so you can see surface body I have created. Actually, you don't no need to worry. You can simply create a this kind of shape over there. No need to worry. Okay, so I'll just, once we created this particular surfaces, now we need to give the connections. Like you can see, this is one surface and this is another surface created. Okay, so now what we need to do is we need to add a um, connections between them. So you need to share this and share at this location, so it will add a share topology over there, so they will share the connections. Okay, so you can see this surface one, or I'll name this as a rib. So right click on it and rename it. This is a rib, and this will be the bracket. Okay, so we have named it. So just no need to give the thickness. Apart from that, everything is same what we have done. Okay, so I hope you understood the model, or shall I repeat it again? Yeah, anyone want me to repeat this?
Yes, sir, please repeat.
Okay, I'll just delete it completely and I'll freshly create it. Okay, so simply what we need to do is, now I will create directly for 2D, so just forget about 3D, so no need. Okay, so simply create a line. So let's say I'm creating a line from the center, and it is of 100 mm. That line is created. Now return to 3D. So we have this line. Okay, take another plane which is perpendicular to this. So let's say we are taking this XZ plane. Okay, and now here we need to create a line. So let's say it is of 100, and then it is of, again, okay, sorry, actually it was not 100, it was of 150 mm. So 150 in horizontal, and again 150 in the vertical direction. Done. Right click and finish the line. Now give the rounded corners. Exactly click on the point and it is of 50 mm. Here you can see return to 3D. So we have this line and this path. Okay, so create a sweep command. So select this line, take a sweep command and then select this as a path. Use control to select all three lines. Okay, done. Say pull full. Clear till this.
Yes, sir.
Clear, right? So surface is created. Now we need to create the rib. So again go to the sketch mode and create a sketch on this mid plane. Okay. Now in this what we need to do is take a projection of the existing sketch. So project this, and this. Now take a line from the midpoint of this to the midpoint of this. Okay. Now trim the excess part. So this one and this one need to be trimmed. Okay. Return to 3D. So we got the rib. Clear? So this is the bracket. We can rename this, right click on it and rename bracket and then done. Clear? Understood? Yes or no?
Hello, sir.
Yes.
Sir, what about holes?
Yeah, holes will create it. So this one is clear till here. So just then we need to share the topology. Before that you can create a hole. So holes. You can go to the design sketch mode and select this plane. Okay. Take a circle and take it from the center. Press shift button to take the reference. So let's say we need to take a reference at 20 mm. Okay, 20 mm. Press shift. Here we have the reference. Okay, 20, and then from there it is of 20. Then return to 3D. Select this surface. Click on delete. It will remove the material. Okay. Similarly, create a sketch on this face. Take a cursor to this center line, press shift and give the distance as 20 mm and give this diameter as 20. Return to 3D, select this face and delete it. Holes are created. Okay. Now what we need to do over here is we need to give the share topology so that they will transfer the load in between. Okay, otherwise they both will act as a separate component. So go to the workbench and click on share and enable the share along all three edges. Okay, sharing is done. Okay, shared three edges done. Then that is how we need to create a model. So any doubt again in this model? Now, then go back to the workbench and launch the model. Okay, so now you can see it is added over here. Now, when you see this rib and bracket, both are available. So let's say we have this rib, its thickness is given over here. So let's say currently we will be adding a thickness of let's say 2 mm. Here you can see before this thickness there is a box. Click on that box. Okay, and when you are clicking on that box, you can here, if you come back to the workbench, here you'll be able to see parameter set is added over there. Similarly, if like a parameter set is added, so just double click on it and it will show you the parameter set. So you can see this rib thickness. This is your parameter set. This is input parameter that you need to change. That's what it is showing in this way, this arrow. This is input. What output you want to observe with respect to this input, that also we need to set. Okay, again go back to this. Now select the sorry, bracket, and now for bracket, let's say we are giving the thickness of 3 mm initially. Again click on parameters. Okay, so this p, it will add it into a parameter set. Again, if I double click on this, here you can see two parameter sets are added. One is a bracket thickness, second one is a rib thickness. Okay, in the output what we need, let's say I wanted to observe the mass of this particular model. Okay, so here we can go to the properties, and here we can see the mass. Click on this, it will show you the mass of the rib, or sorry, if I want a combined mass, so you can just simply click on this sys, and in the properties, okay, here we cannot add. Let me see here you can see this is a combined mass. So total mass of rib plus bracket, that we want to observe what will be the total mass. So click on mass. So let's say I don't want my rib or this complete bracket and rib mass should not exceed like 2 kg or 3 kg. I have some restriction, so you can just check out the mass. So when I go back to the workbench, now here you can see this is the output set added. Okay, here you can see these are the inputs, and with respect to that there will be output. This is output. Here I cannot add this value, that will be calculated from this inputs. Okay, now we have added them too. Okay, now let us create the mesh. So I'll give a 2 mm element size and generate the mesh. Okay, so mesh has been created. So if you want, you can even still improve the mesh. Let's say I will give 1 mm. Generate the mesh. Okay, so you can see the better mesh has been created over here, and there is a contacts also. Okay, so actually we have already shared, so it will not show this contact over here. Okay, so once we done with this, now here you can see we need to go for the static structure. So let's say we are fixing this plate from this face. Okay, so just select this face, right click, insert fixed support. Okay, and let's say on this side or on this edge there is a force which is acting, let's say in the upward direction, so or upward or in the outward direction. So we'll add it in negative z direction. So force, so let us say we have a component, let's say minus 10,000 newton. Okay, so I have added the force. Okay, so here you can just click on static structure. You can see these are the parameters. If you want to vary the force also, you can see this in the force we have this z component. Let's click on this p, that will also be added into the parameter set. This is the input, so you can see it is editable. I can edit this. This is the output that cannot be editable. That will be the result of what we are solving. Okay, or what we are giving the input parameter. Depending on that, it will be changing. Okay, again we need to give a fixed support at this location also. Insert are not required, actually we have fixed the plate on the bottom side. Okay, now we need to check out the results. So go to the solution, right click, insert, let's say deformation, and go to the solution, right click, insert the stress. Okay, so when you go to the stress, so what stress value you want to observe? Let's say I want to find out the average or the maximum, what is the maximum deformation that I want to find it out, and what is the maximum stress. So select the stress. Here also we have results maximum. Click on this box. So this p is added here, also p is added. If you go back here, you can see these two values are added over here. Okay, like this, these two values are added. Now once done with this, So let us solve this problem first. If it is not required to solve, okay, it is up to you if you want. Let us not solve here. So here you can see we have given all the inputs and what output we need, that we have given all, right? So let us say I want to change these combinations and find out the result. So right click on this DP0. Here we have option duplicate design points. Okay, now you can see new design point is created. Okay, now add one more. Let's say I want to add four combinations. So again go for duplicate design points, and duplicate design. So total 5 are created. Okay, 0 was the first one. Let us say now I want a thickness of 2.5, and this thickness, this plate thickness also 2.5. Here, okay, it is 2.5, and here I want it as 3, and here 2, and here 2.5, sorry, 2.5 and 3 and 2 and 2.5. So these are the various combinations I have given. Understood? Now with respect to these combinations, what will be the mass of the complete component, what will be the maximum deformation and stress generated in the component, that we need to understand. Now if I wanted to solve one each case one by one, it will be taking long time, right? So instead of that, we can just create this kind of design points in the parametric study, and then here we have option update all design points. Just click on it, and it is asking you to close this some editors, like this editor and this one is will be closed. So say yes, and it will be automatically closed. Here you can just click on this show progress, and it will show you the complete progress over here. Okay, and here you can see now it will start solving. So first we'll get the maximum deformation over and the stress value over here. Okay, and you can see it will be updating. So you can see for design point 0 now it is solving. Even I have just changed the thicknesses, I have not changed the this force input, then this can also be changed over here. Okay, so it is completely up to you how you want to change or what parameters you want to vary, and to you want to observe the results. So you can see for design point 0 results we have received. Now it is solving for design point 1. So you can see weight is already calculated. Now it is calculating the like stress and deformation. You can see for second also it is done. Now we can go for the third one. Okay, for third also weight is calculated. Now calculating the stress and deformation. Okay, so you can see 3 design endpoints are already solved. Now it is solving for the remaining 2 cases. Okay, and you can see solution is completed. Now it is just retaining certain data, and once that will be done, we can see the results. So you can see already we have got the results. So for the first case, you can see we are getting a deformation of 14 mm. Actually it's reopening the whatever the closed editors were there. So you can see 14 mm and 8081 MPa, that was the stress generated. For the second case, you can see the mass is 0.62 and stress or deformation is 21 mm, and the stress is 10,007 750. In the third case, you can see it is again more, since we have inversed the dimensions over here. In the fourth case, you can see it was 2.5 and it was 3. Okay, now in this case you can see we are getting very less stress with this combination and very less deformation as well. So you can check. So let's say you can consider this is the best design point, or this could be the best combination for your particular problem. So that is how you can analyze this. So let's say you want this, so you can just set this as current. Let's say you want to observe the results for this particular case, so right click on it, set as current. Okay, so yes. Okay, once set it as current, then you can go back to the project and you can just double click on the model. It will show the results for that particular case which we have set for the current. Okay, and here you can see this deformation, how it is getting deformed. Okay, they have stresses are generating over here, so those things can be observed over here. I can say this is the maximum stress is 7.5 to 7.6 MPa and the maximum deformation is 13 mm. So that is for this particular case. So that is how you can get the results for the different combinations, and then with this you can understand which case is best suitable for your problem or for your application, and accordingly you can use that. I hope you understood this. Any kind of like anything you want me to ask? Yes. Any doubt? Any query in this complete problem? Is there any query?
Yeah, if there is any query, please feel free to ask.
Okay then, if not, just try this problem and let me know if you have any questions or any help from my side. Okay.
Yeah, can you share the dimensions to the student, the
Yes.
participant?
Just a moment. Okay. So let me share. Oh, sorry. Yes. So this is the model. So what I'll do is dimensions. This is 100 mm. This is 150. Okay. Yeah, this is exactly at the mid. It is 50. Okay, so from this point to this point, I don't know, it's not taking horizontal dimension, but it is 50. I think that these are the dimensions we have. Okay, I got it. So it is 50 mm. Same here also. I hope all the dimensions are there. I'll leave it in little 3D so you can understand. And I'll have this. Okay, so you can try this out. Simple, you need to create a horizontal line of 100 mm and then create this profile like two lines of 100, 150 by 150, which should be 90 degree to each other, and then take a rounded corners of 50 mm radius. That's all. Then you need to create yes. So the circles are at 20 mm. This one also, and the radius is also 20 mm. They are exactly at the mid. Okay. Have you tried? Let me know if you face any difficulty. Yes. Who is creating the model? Can someone share the screen and show how he is creating so that other can understand? Anyone who would like to share the screen while creating the model itself or while solving the complete problem? Yes. Anyone?
Hello, sir.
Yes.
Sir, can you repeat the process of multiplane working again?
Multiplane working.
Like we have to create a second dimensions in right angle plane.
Mm-hmm. See, so I'll go to the sketch. So what you need to do is first create a profile. So in this case, profile is simple line. So I have selected XY plane. Select a define a line from the center and create a line of 100 mm. Line is created. Correct. Now return to 3D. So we have this line. So line is along XY. So we need to create a profile either on XZ or YZ. Okay. So once we created this, okay, so we need to create another profile either on YZ or XZ. Okay, so in this case I want it in a vertical direction, so I should create it on YZ plane. So take a line command again, and it should be on the YZ plane. So select it this way, uh, like this. Select this plane, so YZ is selected. Okay, and okay, so we need to take it along in the vertical direction first. That will go in the horizontal way. Okay, so take this, let's say 150, and then again in the 90 degrees angle 150. Okay, escape, and then go for the rounded corner. Okay, so here you take the rounded corner, and here give the radius of 15. Return to 3D. That's all. So once you return to 3D, now we need to select this line as a profile and take this sweep command and select all these three lines as a path. Use control to select three lines and just simply I think it has had some issue. Just a moment. Okay, so select this line, take a pull command. Okay, I think it's you need to take a pull command, select this line, then take this sweep option, then select line 1, 2 and 3, and you need to click on pull full. I don't know, it's not at all responding. Just this way we need to create it. So I just dragged it. Actually this full option is not getting highlighted. Okay, so this way we need to create a profile. Right now, to create this rib, it should be exactly on the middle plane. Again, middle plane is YZ. So again, go to the sketch mode, take a YZ plane. You can simply click on X axis to create a YZ plane. Okay, say look at. Okay, I don't know, that's also not working for me. Okay, so once we created this plane, now here again take a line command. Sorry, no need to take line command. First take projections of the existing features. So go to the design. Okay, go to the sketch, and then you need to use this you know, this project to sketch option over here. I don't know, for me it's not working. Okay, try till here. I'll just restart this. So space claim, it's not at all responding actually. Sorry, I'll just take new one. I'll just take new geometry. So it's starting the space claim again. Okay, so I'll simply create it again. It's 150 and then 150. Return to 3D. Okay, done. Take a sweep command, select this, select the line, take a sweep command, select 3 lines, 1, 2, 3, say full, done. Then go to the design, take a sketch mode on this middle plane. Okay, and here what you need to do is project to sketch. So project this sketch, and this one. Okay, so all will be projected. Okay, actually it is creating twice, so I'll delete one. Okay, one more time I'll try. This one, and this. Oh, okay. Not the construction line. Okay, so I have created all three. Now take a line command from the midpoint of this till the midpoint of this, and then trim the excess part, this one and this one. Okay, return to 3D. Done. That is how you can do it. To create a holes, again go to the design, take a sketch on this plane, and here create a sketch of like a circle. Take a circle profile, take a cursor to the midpoint, press shift, drag it downward 20 mm, and there create a circle of 20. Return to 3D and just simply again create a sketch on this plane as well. Take a cursor here, press shift, give the dimension 20, again 20, and then return to 3D. Press H, just simply delete, select this and click on delete, so it will be removed. That's all. Clear? Clear with this?
Yes, sir.
Yeah. Please try it. So see, modeling can be any way once you know the tool. So you need to learn the tool first. You should know the different commands, how exactly those command works, and then modeling can be done easily. Okay, anyone trying? You can share your screen. Okay, very good. There is actually no need to create the line. So why we are creating a line is to take a reference, and the same reference can be taken with the help of uh, shift key. So what you need to do is directly take a circle command and take a mouse cursor from where you are starting that line. Directly press shift over there, and it will. Okay, so that extra line is created in between, I feel, that you need to remove.
Yes, yes.
Just click on select S, press S key. You can directly remove it, just delete it, select it and delete it. It will be removed and it will be a continuous surface. Yes, same on other side. Okay, there it is, not there. Fine. While creating the rib, you didn't trim that part, so it was
It
there.
is done, sir.
Yes, now it is clear. Yes, anyone else who have completed or getting any difficulty while creating the model itself? Yes, it is correct one. Very good. Yes, what about next? Have you given the conditions? Yes, anyone who can show me the screen? Yes, please show me the screen if you have completed or if you are solving the problem. Yes, anyone completed? Or shall I start calling? Yes, anyone completed or not? Or shall I directly move to the next problem? See, we are giving time to practice so that you can understand. Otherwise, we can just simply, finish it, the complete topic. So, but that won't be a fruitful session for you. So, make sure that you'll, you know, take a complete advantage of this. Let me know if you have any questions. Anyone who have completed the problem?
Yeah, if anybody has any query, please do ask, or if you have done, you can share the screen.
Okay, so we'll wait for 2-3 minutes. In fact, you can show the screen while doing, so I can help. Yes. So you have just added the mass as a output. So we even need to add, stress as well as the deformation as a output parameters. So that also we need to take care, right? So you need to add them as over there.
Yes, sir.
Why it is not solved? Have you added another combination? Okay, you're adding the results. Mhm. Now we need to resolve it. Okay. Okay, who else would like to share the screen? Come on, be quick. So we'll solve one more problem after this. Yes, anyone? Okay, so there is a error coming. Why? What is the error? Click on fix support. Click on fix support. Okay, you have given a wrong fix support. Yes, now it is correct. And click on force. Hmm. Just show me the screen again. Sorry, I was talking but muted. Hello. It was not solving, right? Please show me the screen. Hmm. Oh, okay. Just expand that first geometry imports. What is that geometry imports? Click on that geometry import first option. Can you show me the workbench? Okay. Again, go to the mechanical. Just click on that geometry import A3, right click on it, and if possible try to okay, replace. Why that part is added, I am not getting actually. It is some extra thing that is added over there. Click on static structural once or mesh. Let me see the mesh. Okay, it is give the sizing of 2 mm in the mesh in the element size bottom side 2 mm 2 mm. I don't know if the internet is delayed. Okay, then update the mesh. Okay, now right click on static structural and solve. Click on force.
Hello, sir.
Yes.
In Workbench, we have to click on share option. So maybe.
Sharing is done. That is the reason there is no, it's not showing the connection. Otherwise, it will show connection. There is some extra component coming, geometry imports. From where it is coming, I am not getting that. And can you right click on the geometry imports and delete it? Try to delete that on the top side. Okay, there is not upper side that above there is also one more geometry imports name is there, right? Okay, it's not coming. Can you go back to the workbench? Workbench. Okay, just take a new static structure and drop it on the geometry. Drop it on the geometry. Yes. Now double click on that model. Next. Okay. Here also that is coming. Go to the specimen. Go to the file and save this. Okay, first go to the workbench. In the center we have that workbench tab. No, there in the specimen itself. In the space claim and the share, click on share just below that workbench name. Share, first option. Yes, click OK. Green tick. Now go back to the workbench. And double click on that model in the second window. Second structure. Yes, click on yes. And now on the go to the mechanical, then bottom side, second window you should select. Okay, in the mechanical, it's still showing second. Now go to this SYS in the geometry, expand that, plus, click on plus, and then give the thickness. Okay, click on that thickness P. Next, yes, same. Okay, have you done it for both parameter set? Okay, then create a mesh of 2 mm. I don't know, still that geometry import is coming over there. Okay, go to static structural, add fixed support. Select the bottom side. No, not on top. Select it from the bottom. Okay, click on apply. Edge selection. Apply. Vector to components. Press H key. Okay, give 1000 Newton. And solve the problem. Never directly click on that top solve. Just need to right click on static structural and solve. Every time keep this in mind, everyone. That solves the complete process. Never attempt that. Okay, it is solved. Now add the result. Add another stress result. Right click on solution and solve. Now go to that deformation, scroll down in the details and click on maximum P. Yes, same for the stress. Okay, then you can go to the workbench and then double click on parameter set. Just that left side enlarge, right side enlarge it. Right side. Expand the right side or just No, 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 not left, right side I say. Yes. No, right click and create new design points. Right click on DP0, not in the blank. Duplicate design points. One second. Uh, just go back to the that mechanical of first window, first one. Yes, and wherever you have added this parameter set here, just remove that surfaces. Click on surface and that remove that P, that box. No, 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 the thickness, yes. Same for other. Yes, and now go back to the workbench. Okay, now you can give the combinations. Okay, so you can solve this way. Anyone else? Any other query? Anyone who would like to show? If you have any doubt, like how that was not able to solve, so we can help to solve the problem. Yes, anyone? No one wants to share screen. See, those who are sharing the screen, they are able to clear their doubts and they are, then able to take a complete benefit of this. Others won't be able to get it. Okay, no issues. We'll move to the next problem. So I'll just take a new window. Sir, is there any provision to share the model? Can I get any mail ID on which I can share and then you can just circulate in with me through mail or something? Is it possible? Hello, sir. Okay, by the time we start the problem, so we are going to solve a thermal analysis problem. So we have this steady state thermal. Okay, so here you can see I have taken this steady state thermal analysis system. I'll show you the problem first. Go to the mechanical and so we have this particular problem over here. We have this complete pump housing over here. So this pump housing which is kept at or which is exposed to different temperatures at different locations. So you can see this inner surface. So this surface is exposed to interior which of the pump where the fluid is contained and it is at 90 degrees Celsius. Another thing is this mating surface. It is held at a temperature of 60 degrees Celsius, and this outer surface which is exposed to a temperature of 20 degrees Celsius or which is exposed to air at 20 degrees Celsius. Okay, so these are the three conditions for here. So go back to the workbench. Now we need, I do have this model ready with me. Okay, so just need to go to engineering data. So let's say we want to compare for the two cases. So one is a metal and another one is a plastic. So I'll go to engineering data. I need to add both the materials, right? So let's say I'll add aluminum alloy and polyethylene. Okay, so add both the materials, click on plus, and here you can see both the materials are added over here. Simply close this engineering data. Now geometry we already have, so I'll just right click on geometry and import the geometry and then just select the geometry pump housing.stp. So double click on it. Just a minute. Okay, so here you can see this model is here now. We can see the model here. Now we have to apply the various conditions. So we can say this is the housing. Now let us create the mesh. So I will just directly give a mesh size of 3 mm and generate the mesh. So everything is same. Instead of applying the static structural boundary conditions, here we can apply the thermal boundary condition. Okay, and in this case, if you go to engineering data, here you will be able to see only thermal boundaries, that is thermal conductivity and material field variables. You can see along with that change in the temperature. Okay, you can see the complete data over here. Okay, so these two values only that we are getting here. Okay, so you can see all the materials as well as their properties here itself. But in this case of mechanic or thermal analysis, only the thermal properties which are important over here. Okay, so in which you can see this isotropic thermal conductivity and specific heat constant pressure. Okay, so these are the thermal properties which are important over here. Now we have this model with us. Now we need to apply the boundary condition. So right click on steady state thermal, insert, and you can see only thermal related boundaries now. The first one is the temperature. So we need to apply temperature on this surface, all the inner surfaces. What you need to do is select any one surface, and here we have option extend to limits. Automatically the selection will be extended. I'll hide this mesh so you can see it very carefully. Okay, so it is selected. Click on apply, and on this surface temperature is 90 degrees Celsius. Now you can see the unit is 90 degrees Celsius. If you want to change it, you can go to the home units, and here you can see if it is in degrees or Celsius or Kelvin, you can change it. Okay, now this surface which is exposed or which is connected to other part of the pump housing, which is at 60 degrees Celsius. So select this face, right click on steady state thermal, insert temperature to this face which is at 60 degrees Celsius, correct? And then now this outer surface which is exposed to air at 20 degrees Celsius. What it means by exposed to air at 20 degrees Celsius? There will be convection from the surface of the this pump housing to the air. Okay, so we need to add a convection boundary condition. So go to steady state thermal, insert convection, and where we want on all the outer surfaces. So select any one surface again, click on extend to limits. You can see all the outer surfaces will be selected. Click on apply. Now film coefficient, if you have value you can directly add it, or I want to import it from the tabular data. So here you can see import temperature dependent, and I am going to take a simplified stagnant air simplified case. Okay, so you can, it's just a value that we are getting. So if you don't know, you can direct, if you have direct value you can directly put that value, doesn't matter. And this air is at 20 degrees Celsius. So add that, and that's all. We have added all the boundary conditions over here. Simply right click on steady state thermal and solve the problem. So very simple it is, and you can easily solve. Okay, once done, now right click on solution, insert thermal temperature. Again right click solution, insert total heat flux. Okay, again right click on solution and evaluate all the results. And here you can see the temperature variation. If I remove the grid, so you can see the complete temperature variation. Since it is a metal body, so you can see complete heat transfer is taking place from the inner surface to the outer surface. Okay, so you can see temperature is varying from 60 to 90 degrees Celsius. Okay, okay, now You can see the heat flux. You can check out the direction or vectors of the heat flux over here. Okay, now important is how you can see this temperature variation. Now actually we have solved it for the static structural. We supposed to change the material. So I'll just go to this pump housing again. Material assignment, change it to uh, aluminum alloy. Okay, and then again I'll solve it. Okay, you can see the temperature variations again. So this is for the metal. So I wanted to again have the same results for the plastic also. So what I will go do is again come back to the workbench, click on this arrow and just duplicate this. Okay, and here you can see its copy will be created. You can name this anything like this is for the plastic and this is for the alloy. So you can name that as well. Okay, so just again double click on setup. Okay, so you can see here just need to go to this geometry again, select this pump housing, change the material from aluminum alloy to polyethylene and solve the problem. That's all, because everything is same. We just need to find out the result for the other we can say the plastic material. Okay, we can go for parametric study, but there we can only see either maximum, minimum or average temperature, but we cannot see the complete temperature distribution. So in that case we have just duplicated, and here you can see this is due to plastic material or having a less thermal conductivity. Here you can see there is no heat transfer taking place from inner surface, or it is very less, as you can see. Okay, so that is how we can make a comparison out of this. Clear with this? Any doubt in this complete portion?
Oh, sir.
Okay. So, sir, how I can share this geometry with the participants? Is there any way? Okay, you can upload it here. Okay, just a moment. Okay, I think there is a folder which is shared. Fine. I'll upload it there. Okay, it is already there. Okay. In that particular folder, pump underscore housing dot stp, that file is already there. Okay, so you can try it out. So I hope that folder is already being shared with everyone. So we can just, sorry, I couldn't get you, Abhinandan. So is it not there? Because I can see it over there. If you open this particular file or this particular link, it is already available in that link. Okay, no doubts. Okay, okay, great, great. Okay, just try it out. Let me know if you have any questions. Okay.